So good morning, everybody. Along with my co-organizers, Professor Ramesh Curry and Gary Mack, I want to welcome everybody to today's panel discussion on additive manufacturing security. We want to acknowledge the National Science Foundation for providing funding to make these events possible. This is the fourth panel discussion under the theme of manufacturing security. The recordings of previous events are now available on YouTube, and the links are provided here. They are also on my website. Today we have three panelists, and the panel will be moderated by Professor Dimitrios Serpanos. He's a professor of electrical and computer engineering at the University of Patras and director of the Industrial Systems Institute. He received a PhD in computer science from Princeton University. He has been working on computer architecture, network systems, and embedded systems for more than 25 years, with special emphasis on building real systems and prototypes that are tested in the lab or in the field. He has published more than 150 papers in refereed international technical journals and proceedings of international conferences. I want to sincerely thank Professor Serpanos for agreeing to moderate this panel. And now I will hand over the floor to him. Thank you very much.
Okay, thank you very much for your invitation, and I appreciate the opportunity to coordinate this interesting panel with an interesting subject and a great set of panelists. I would like to welcome, first of all, the panelists, Chris Adkins, Professor Meinel, and Professor Yampolskiy for accepting and participating in this panel. So, as was mentioned, I am a professor. I'm also directing a research institute which is called Industrial Systems Institute, and manufacturing is part of the application domains that are of interest to our institute. So I have been working in this area, especially related to cybersecurity in manufacturing for several years, addressing aspects that have to do with both security and safety. And the couple of things that I would like to mention before giving the floor to the panelists is that actually, manufacturing is an application domain where computing started being employed and adopted for several, from the beginning of computing for several decades now, influencing the automated processes in manufacturing. Through the years, it has grown to more complex systems like PLCs, SCADAs, and so on. And as a computational model, it has, gone through applications in several aspects of today's critical infrastructures, ranging from energy, water management, manufacturing, health, and so on and so forth. So considering now the growth of Industry 4 and the industrial internet, all these aspects have become very important for economic growth in nations. And one of the major concerns in all these applications domains, of course, is cybersecurity, especially in light of real events like the Stuxnet, the Ukraine attacks on the energy systems in the near past. And this creates a great, I think, opportunity for research and as well as education in an emerging area that is becoming increasingly complex. Our panelists today are coming from different paths, industry and academia, and I'm sure they will shed light in identification and modeling of threats and proposing solutions for this increasingly important problem of cybersecurity in industrial systems and especially in manufacturing. The way we are going to hold the panel, actually, I'm going to give the floor to our three panelists to give a position statement for a few minutes, and then we will go through some rounds of questions that are interesting, and we will be following, of course, the chat in the Zoom system to see if there are questions that relate directly to what the panelists are saying, so they can address them directly. So in that respect, I would like to invite first Professor Meinel to give his statement. And just to mention here, Professor Meinel is CEO and Scientific Director of the Hasso-Plattner-Institut for Digital Engineering, as well as Dean of the Digital Engineering Faculty at the University of Potsdam in Germany. He holds the Chair of Internet Technologies and Systems and teaches courses in IT Systems Engineering on the MOOC platform OpenHPI and the HPI School of Design Thinking. His research focuses currently on security engineering, knowledge engineering, and Web3 semantic social service web, and he's scientifically active in the design thinking research. He has published widely papers in books, papers, and in journals and conferences, holds several international panels. He is a member of the National Academy of Science and Engineering, director of the HPI Stanford Design Thinking Research Program, and so on and so forth. Professor Meinel, the floor is yours for your position statement.
Many thanks, Dimitrios, for introducing me. Welcome. It's an honor to be invited to your panel. I would like to share the screen to show you one slide, a little bit in an overview what we are doing. Could you see this? Here I want to shortly describe what we are doing in our security research here at the Hasso-Plattner-Institut. Hasso-Plattner, that's the founder of SAP, is something like a German Bill Gates. He runs this institute about all facets of digital technologies. My chair, you introduced it already, is Internet Technology and Systems, and with one focus on digital education and the other on security. Here with the slide, I have a few keywords, what we are doing in the institute when we do research in security. There is a one side, this is concerned with a human using such secure systems, secure technologies, that is security awareness and digital alignment. I want to share one single research area which shows that it's very important not only to develop secure technologies and to technology to secure systems, but also to educate the people. So there was a couple of years ago identity leak with from Adobe in that time, with millions of identity data sets, name, address, the bank account, credit card, password, email, so all what you have, all data you have to give to establish a digital identity to get an account with an internet service. And there was this leak, and so we thought, oh, we should inform our students. We find indeed some of our students which where their identity data are published in that leaked and are open now to the internet. So we start systematically to look around, not in the dark nets, in the internet, about such leaks, and establish a service that people can check at hand of their email address whether their identity data are open, available in the internet. So over the years, meanwhile, we collected more than 12 billion such identity data sets. And this was very much astonishing for us. It's a big number, of course. But when we analyzed these leaks, we found out that in about 1/3 of these leaks, the password is not hashed. For the non-specialist, a password is not allowed to be stored in the clear text on the side of the server. It has to be hashed. This is a technique to make it unreadable for the administrators, as well for the cyber criminals that steal such data. 1/3, 4 billion data sets, we can see the password in clear text. And about 5% of this, so several million of people, use the password 1, 2, 3, 4, 5, 6. Up to 2016, it was 1, 2, 3, 4, 5. Then Microsoft insists in at least 6 digits, and so they do. Now one can say there are many million people which are stupid, but I think it's not the right conclusion. The conclusion is there are many million of people that do not understand why they need a password. That it is not a ritual to access an IT system. No, it is only for securing their own data. And this is one trigger that we put a lot of effort in training and educating awareness, so that the people understand better why security systems exist, what they help to secure, and how to use it. So our institute run the biggest European MOOC platform, massive open online courses for such digital content, and an important part of the MOOCs published there is going on security. This was the left side. The right side of my slide shows what we do in the context of using big data analytics technology for checking the security situation in a company or in an organization. Next-gen security engineering and our system, real-time event analytics management system, is the goal. What you have on the market are huge systems that are able to tell you tomorrow that yesterday something happened. Our goal is to detect in real time if their attacks are going on. So this is our research. We do attack graph analytics for that, and we also use our knowledge about stolen identities to bring all this information together to find out the security situation of a system. Perhaps this is as a starting point to give you a little bit the background of what we are doing in our research, what we are looking for, and I am looking forward for our discussion. Dimitri, we cannot hear you.
Dimitri, you are on mute. I'm not sure if he's not able to hear us. But I would request Mark to start his introduction and maybe give us
sorry.
remarks.
Sorry, I'm back. I had a network problem. I apologize for this. So I was just saying that thank you very much, Professor Meinel, and I would like to invite our second panelist, Chris Adkins, to give us his position to the statement. Chris Adkins is the chief scientist at ADDITIVE 3D, where he leads the security architecture development. Chris works closely with the product and engineering teams to integrate emerging digital manufacturing and cybersecurity technologies into the ADDITIVE 3D ecosystem. Prior to joining ADDITIVE 3D, Chris directed the industry-leading anti-counterfeit technology development for Lexmark International. During his time there at Lexmark, he led research and development efforts in security, inkjet printhead, and motion control areas. He holds 50 US patents. He has earned his bachelor's and master's degrees in electrical engineering from the University of Kentucky, where he is originally from and lives with his wife and 3 kids. So Chris is going to talk about research, safety and security challenges in the digital thread in manufacturing. Chris, the floor is yours. Thank you.
Thank you, Dimitri. Let me share a few slides here. So hopefully you can see my screen now. So I work for ADDITIVE 3D now. We're a software startup company, been around about 5 years. We focus on the digital manufacturing space, making sure that there are security within the space, particularly around the repeatability, IP protection, and the traceability. And I'll go into those overview and a little bit later as we get into the Q&A. So one of the things that we see with digital manufacturing is it enables manufacturing to be distributed. So if you look at traditional manufacturing, there was a very close tie between the engineering side and the manufacturing side, where the engineering side would help the manufacturing group set up a dedicated manufacturing line environment that would last, a very long time, the lifetime of the product. There's a lot of investment required to do that. There was a lot of dedicated equipment just for a single process. And there were very few of them geographically. But because of that, the distribution, the inventory was very complex. So with digital and distributed manufacturing, what that enables is the manufacturing of parts as they're needed, where they're needed. So instead of having to create a physical inventory of parts waiting for the orders, you have a digital inventory where you created the IP. The IP of the parts is all developed within digital files, and they're sitting in a database inventory waiting for orders to manufacture those. And then you have a lot of distributed sites, oftentimes very close to where the end customer or the assembly is going to happen. And then orders come down as soon as those parts are needed. And then these distributed manufacturing sites then will make the part and ship those to the end assembly or the end customer. But that creates a lot of issues. So particularly now that since all the IP is within a digital file, if you've developed the R&D around that part for many years, and a lot of times maybe developed using a large engineering team to develop that, there's quite a bit of money around that IP, and you don't want to have that stolen either through a manufacturer or a contractor, a supplier. So you want to be able to keep that, but that's very challenging now, and we'll get into that some more in the Q&A. Additionally, you have compliance issues where if you controlled your own manufacturing or you had a very limited manufacturing set, being able to do compliance was easy. But now if you're depending upon many very small manufacturers who do just one subcomponent, then being able to be assured that they are always in compliance is a big challenge, especially if they're not in the same geography that you're in. Traceability becomes an issue. Knowing what goes in and what comes out of that shop is very difficult to do. Again, if you're depending upon lots of small shops. Operator error. Previously, if you controlled the manufacturing shop, you were able to train the operators and made sure that they were qualified. But now, if you're depending upon small shops, those small shops are doing lots of different parts, and they may not have good training on exactly what your part should look like. They may not be able to do the quality control that you would normally want to be done. And certainly the operators are not going to have the experience that they would previously. And then the final thing is the counterfeit products. So if you're providing IP to a contractor to make a part, you want to be sure that they're only making the number that you paid for, that they're not making an additional number and selling them in a black market, for instance. And you'll also make sure that they're using the supplies that you've required, and they're not getting a cheaper supply of material that may not stand up to your functional requirements. So all of those challenges are now presented as we go to a digital and distributed manufacturing process. As a matter of fact, each time and each process includes sharing of data and sharing of files. And that's an opportunity for a cybersecurity attack on the data side. And it gets very difficult and very challenging based on the type of equipment that's being used in a lot of these shops. So I think we're going to talk some about some of these challenges in the Q&A. So I look forward to that. Thank you.
Okay, thank you very much, Chris. Let's pass the floor to our third panelist, Mark Yampolskiy from Auburn University. Mark is an associate professor at Auburn University since 2019, joining after a term as faculty at the University of South Alabama and after research work at Vanderbilt University. He holds a degree in applied mathematics from the Moscow State Institute of Radiotechnics, Electronics, and Automation in Russia, and a PhD from Ludwig Maximilians University in Munich, Germany. His research work focuses on security of additive manufacturing, and he's going to talk to us about cybersecurity challenge in this specific area. Mark, the floor is yours.
Thank you for the introduction, Dimitrios, and thank you very much for the invitation to this panel. Let me also share a slide. Let me figure out. Okay. I would like to start just emphasizing the fact that this research area is extremely new. And a couple of years ago, we published, my collaboration partner Syntag published a comprehensive survey. Back then, it was only 67 papers have been published till the end of 2017. And you could see that the initial research has started around 2013, 2014. Actually, 2014, first real technical papers have appeared. And then you see that the interest to this research area is growing, and about 2 years later, the amount of publication doubled. We have over 200 authors that work in this field or worked in this field by that time. Meanwhile, it is more. And what is also interesting, and especially for us, for people who are concerned about security, it is important to understand that this research area is not limited to United States. So, okay, last year, or by April 2019, there have been research from over 14 countries. And you can imagine that when research gets public, not everybody is with benign purposes, okay? So, like I mentioned, the research area is very new, and we have also a fairly disconnect between what is going on in the industry. Like Identify 3D is focused on the industry, and I'm mainly interacting with the research community. And in research community, academia, we have huge disconnect between what we are doing and what is really needed. And just to give you one example. Majority of research that has been done so far has been focused on desktop 3D printers with FDM technology, which is good for polymers. To some extent, it is also used for composite materials, but it has absolutely no relevance for metal manufacturing and, like I mentioned, little relevance for composite materials. And if we are thinking about where additive manufacturing really matters and where quality and intellectual properties that Chris has mentioned really matter, it is manufacturing with metals and composites. Because these are products that are going in safety critical parts like airplane or rocket or jet engines. And we need to make this transition because if you look at the bottom, FDM 3D printers are fairly simple and stupid. PBF or DD 3D printers are very complex machines, and it doesn't. Therefore, I would argue that solutions that we develop for FDM 3D printers will be only conditionally transferable to more complex industrial grade systems. And another thing that I want to mention, and I could talk about where we stand and where we need to go for at least 1 hour. So another thing that I like to mention is that majority of us have education in one specific field. I'm coming from computer science. I have security background, so I came from this angle. I know that many researchers coming through material science or additive manufacturing, like mechanical engineering, and all of us are trying to do some research on security of additive manufacturing. And here I want to emphasize that. And I understand that working with colleagues who speak your language, who understand what you are thinking, it is easy, it is pleasant, and encouraged also. But when we are dealing with security of additive manufacturing, we need to understand that it is a highly multidisciplinary discipline. It doesn't mean that, okay, no matter how smart you are, no matter how much you know, you will need to work with experts from other research fields, because to address security issues in additive, we need to know, obviously, cybersecurity. We need to know security of cyber-physical systems. That is not exactly the same like cybersecurity. We need to have expertise in material science, maybe mechanical engineering, etc., etc., etc. And really, this is what I really would like to emphasize. And if you forget everything else, what I say is today, just remember that if you want to work in this area, you really need to build teams that are multidisciplinary. And here I want to transfer back to Dimitrios.
Okay, thank you, Mark. Appreciate your position. So based on your positions, and let me get a little bit of discussion starting with a little bit focusing on the subject a little bit further. So let's go through a round where we discuss a little bit about what kind of threats we see in the area of manufacturing. If you allow me, I will start with Professor Meinel, asking him, since he's coming from Europe, and Europe has been a leader in Industry 4, you know, and the activities of Industry 4, which address all aspects of cyber-physical systems in lots of domains, including manufacturing, of course. What kind of major cybersecurity threats do you see today, and how do you see their do you foresee their evolution in the near future in the manufacturing domain?
In fact, the question of cybersecurity threats of risk in the field of what we call in Europe Industry 4.0, in US it's called industrial internet, is really a wide range. Let's start with the cyber physical systems which are characteristics this area. The idea here is with the industrial internet that the machines, the objects, they can use the internet for communication like human can do. And in this way, it's possible to let the objects directly interact with each other. The idea here is you have a machine and then you have a small cyber unit so that the machine it can receive and can send communications, electronic communications. They can collect by means of sensors, they can collect data. And then this data are brought together to control units and used there. So the first point we have, if we look to this level, is that many of these cyber-physical systems are not securely designed. These are very small pieces of logic, small processors, because it's distributed over the environment, over fabric hull or other things. So often there is not enough security mechanisms to secure the communication of these devices with each other. Next point is the sensor data that are collected, that are collected over many such devices and are fed into control systems, which transport this data over the internet, for example, in a cloud or in a computing center to perform the control, to make the computation. And here we have the risk. What happens if this data are transported, if this data are communicated? Is there access from anyone? For example, simply by disturbing this communication, the attacker can disturb the cooperation of the machine, the usage of the system, the functionality. When this data are transported over the internet, we have all the risks that are provided by the internet, by internet communication. If we look to the centers where this data are computed, to the clouds, then we have risk, security risk inside the cloud concerning the data, concerning the taking data away for espionage or for other things. So you really see there is a wide range, and to discuss details, one has to look for which part in this long chain we have to consider. So I think for the first, it is enough, and then we will see in our discussion in which point we want to go into more details.
Okay, thank you very much. Chris, I would like to ask you a little bit on the same subject, but extend the question a little bit. So how do you see the cybersecurity threats increasing? Are we move towards increasing automated and distributed digital manufacturing? But considering also your experience in industry, in real life, let's say, not academic life, what kind of problems do you think are more important in practice? For example, we hear that the role of trusted data in the manufacturing process is increasing. How do you address the problem of managing such trusted data in the context of digital manufacturing, in the workflow, where you are working with subcontractors and so on? How do you manage, do you expect to manage the supply chain in this direction?
Yeah, it's a great question, and one that's very practical and very challenging at the same time. So I think what we see a lot in the industry is, especially around the defense industry, for instance, is you have a few very large prime manufacturers, prime contractors who oversee the entire product. Obviously, those are very large, multi-billion-dollar enterprises, and they have extensive cybersecurity protections around their data, around their manufacturing systems. But if you look at their supply chain that they're depending upon to create the final part, there's a lot of very small players in the middle of that. So as we move towards automated and digital manufacturing, there's this enormous amount of data that has to be shared throughout that supply chain. And at the end of it, you're dependent upon very small players to manage this. So you have a large enterprise with extensive cybersecurity sending data to a very small player with almost no cybersecurity protections. So, and if you look at a lot of the equipment that those small players are using, they're often using equipment that may be 20 years old. If you're talking about CNC, even additive manufacturing equipment, a lot of times does not have what I would call very robust cybersecurity protections built into it. So the equipment doesn't have the protections. They don't have their own expertise, and many times they're getting data through email, which obviously is brings up the very basic attacks, phishing attacks, and ransomware that these small players are fighting with. So you have the large players who are defending against nation attacks and doing a good job, but at the end of the day, their products are being made by very small players who have very little protection. And the equipment and processes they're using as they buy them off the shelf are not really coming with any protection built into them. So it's pretty amazing to look at a standard manufacturing process. Often you'll see Windows XP computers in the middle of the process because they've been working for 20 years and there's no reason to change them until they stop working. So it's a very difficult problem to be able to share data. If you're a big player and you want to take advantage of distributed manufacturing, then you have to be able to trust small players. And that's a very difficult and challenging thing to do. And there's really no good solution that's widely available yet for that.
Okay, Chris, thank you very much. I appreciate your answer, very enlightening. So I would like to ask Mark. Mark, you have been focusing a lot on specific parts of manufacturing like additive manufacturing and direct digital manufacturing. So how do you see the various parts, let's say, domains of manufacturing being affected by requirements for security and safety? I mean, what kind of difference do you think is necessary for cybersecurity solutions and safety solutions in these domains? Can you give us a better idea about what cybersecurity means in these specific directions and how it relates to the solutions in other parts of manufacturing?
Thank you for the question. I think it is excellent lead on to actually my research area, because I think that cybersecurity is a integral and critical component of whatever solutions we will develop for additive manufacturing. Because without cybersecurity solutions, we will just leave our door open. And there are some anecdotal stories with companies, like Chris has mentioned, small companies, and anecdotal story is that the company put newly bought 3D printer directly on the internet, and default credential, username, and password was enabled. And only 2 or 3 weeks later, some system administrator was wondering why printer, not even 3D printer, but printer is accessible from the internet. So, and therefore, cybersecurity is extremely important, right? At the same time, I would also argue that we cannot limit ourselves to the cybersecurity only. We also need to consider different avenues of attacks and different scenarios under which attacks can happen. For example, Chris has mentioned distributed manufacturing, and I understand this and the benefits of distributed manufacturing, but it also opens us to the possibility of some manufacturers being malicious or having malicious insiders who would like to get access to the data. And then the question becomes, are the cybersecurity solutions like encryption, even TPM modules on the 3D printer, and you can exercise through different scenarios. Are they still sufficient for a sophisticated attacker, right? Who has time and resources to conduct something like side channel attacks? And it has been already shown with certain degree of quality that it is possible to obtain the manufactured part design based on the side channel observation. And my question would be, this is where I would argue that additive manufacturing security is broader than just cybersecurity, but cybersecurity is needed. We cannot just say that, okay, let's abandon cybersecurity solution. I would just say, let's implement cybersecurity solution, what Identify3D is doing. I think it is the way to go. And on top of it, we also need to make a thorough analysis of VR limitations and what other maybe organizational measures or other physical security measures need to be added on top of the solutions that are developed.
I see. Very interesting. Thank you very much, Mark. Based on the discussion up to now, actually, we have gone towards some issues that relate to supply chain, the supply chain of manufacturing. So, which in my view presents several interesting security and safety problems. So coming back to Professor Meinel, I would like to know, since I understand that he's working a lot also with cloud-based solutions, how do you, Professor Meinel, envision the integration of the cloud in the future of manufacturing solutions? And how do you think the future threats are going to be influenced by inclusion of the cloud?
The cloud technology provides a huge advantage compared to the old organization of providing computing centers, which are owned by a company or by an organization and are regulated and proceed with this. The cloud provides a possibility that you get such kind of resources in that moment you need it as much as you like. So this is a technological big advantage. The question, what happens with security risk compared to a computing center owned by a company, fully controlled by a company with all the data sets and so on. Here you use a shared infrastructure with many other customers. And there we see new risk in several points. There is some very obvious risk is if you give all your data, all your systems to a cloud provider and ask him to run this system and to process the data and analyze the data for him, then of course the people of this cloud provider have access to the data, have access to the computation, can control this computation, and in particular this famous cloud models where you, of the public cloud, where you can use this infrastructure for paying nothing or paying only a few amount of data. Of course, this is something one should think about. What are the consequences? If you use such services of a public cloud, then the provider of that cloud has to earn the money that's needed to run this infrastructure in a different way. And the typical business model is to analyze the data, to pay the data, to pay analytics results of the data, or to let the service provider offers this data for paid for analytics or for the others. So one has to be very careful in using this public cloud infrastructure. Of course, one can also make a deal with this cloud provider for a higher security of the data, or to guarantee that to get a guarantee that the cloud provider is not give your data away for analytic purpose and other things. This is one problem. The other security risks are that, of course, such cloud provider are interesting goals for security attackers, starting with denial of service attacks to hinder the use of the data, up to more dedicated security attacks, for example, inside the cloud, to get access from to other companies, to other customers' data as a customer in the cloud. So there is a wide range. It's a wonderful new possibility to get computing resources without taking care about the organization of the service, take care about the administration of the service, but it provides, on the other side, a lot of new security risk, particularly for your data. Vendor login is another keyword that is important at that content.
Okay, thank you very much. Mark, I would like to ask you if, based on your experience and your knowledge of the field, if you have any data indications, or if you have any expectations that specific manufacturing sectors are going to be targeted more than others. For example, automotive, aerospace, medical, or anything like that. And as time is passing and we are coming to a close for our panel, I would like to ask you also, as a second part of the question, if you could give us an idea about what steps you think could be taken to reduce risks, security risks in manufacturing, and what kind of technologies you think should be included in the various domains of manufacturing to defend against potential new threats.
Okay. Very good question. Unfortunately, I don't have answer to the first part because, to my knowledge, there are no specific attacks on additive manufacturing systems have been recorded in Beirut. Again, it is to my knowledge. I might not know everything. At the same time, I would assume that it is only a matter of time, especially because in additive manufacturing, like Industry 4.0, everything is digital. It makes it easier to steal technical data or intellectual property, if you want to call it this way. And it also makes it easier to modify technical data and with this making sabotage attacks. Who will do this? Probably competitors want to steal technical data. And there are also more than enough reports for even state actors trying to sabotage critical infrastructure, and they have also the interest, or you can think about ransomware. So as soon as reliable business models evolve, I think we will see real attack in the world more and more. As of second part of your question, I know that current solution is to unplug 3D printers from the internet, create air gap, and because operators just are scared about everything what has to do with cybersecurity. And cybersecurity people know that it is not a solution, or at least not a reliable solution for a long run, because you can even breach air gaps. Or at least sophisticated actors can do this. So we really need some new solutions, like the ones that Identify3D is working on, especially if you want to enable all the benefits of this new technology with the flexibility, with the distributed manufacturing, etc. Because one way or another, you will need to have access to the internet or to some sort of a network. So right now, it is Wild West.
Okay, thank you, Mark. We have a few questions on the Q&A, and actually they relate to the last question that I had in mind. So if you allow me, I will try to combine everything together, and I apologize to the attendees if I do not address exactly all the aspects that they have brought up. And I would like to ask Chris as a last question, because we are coming to an end, and he mentioned the aspects of sensitive data. And it seems that some of our attendants are worried about the risks that have to do with data integrity issues, especially for modifications of customer specifications when they are transferred, identity theft issues, and so on and so forth, which all relate in some sense to the supply chain and the aspects that you discussed earlier, Chris. So let me ask you that, as you mentioned, the defense industrial base is actually facing several challenges, especially the small businesses. There is a trust issue, and trust solutions are coming up. In this direction, do you think that technology, for example, is the only solution? One of our attendants asks if there is a role for policy to address problems like this and make manufacturing a high priority. Do you see a role for technology, a role for the industry itself? And what kind of opportunities do you think we have, or directions for research that address these aspects of the integrity of the supply chain and the specialized cybersecurity risks that we associate with manufacturing today?
Sure. Yeah, great question. Those are big challenges, and as you mentioned, the defense industrial base, there was a paper, a study that came out by the RAND company this year talking about that, and they have looked, and from their estimates, there's 72,000 small businesses in the US involved in the defense industrial base, and most of those manufacturers, and their estimates too are that very few, or if any of those, have sufficient cybersecurity defenses. So there's a lot of players, and obviously there's a lot of attacks, and especially in the defense industrial base, those attacks are coming from nation states. So for a small player to defend against those, it's almost impossible. And the other thing that's very challenging on the supply chain side, when you talk about data protection, is you just can't buy a piece of software or a technology solution just for yourself. You have to share data, so you have to share solutions across everyone in the supply chain. So as we develop solutions, that's really core to what we do, is allowing multiple entities, multiple companies to be able to share data all the way from not just from human to human, but from a device to device, so that a additive manufacturing machine can pull in an encrypted data set with an authorization to print. And that, as part of the authorization, they'll decrypt as well as check the integrity to make sure that the files haven't changed, but they also stay private between those entities. But I think one of the very important things as we look at security solutions is being able to develop solutions that are easy to use, especially at the level of the operator or level of the shops. As Mark was saying, one of the things, the first thing to do if someone is setting up a new additive manufacturing machines is take it off the network if they're concerned. But there's a lot of focus now, not just on data to the machine, but data from the machine. So, a lot of times there are embedded cameras, imaging systems that are taking multiple pictures of every slice. So machine by itself will create a terabyte of data per day. So there's no way really to manage that data offline. It's got to be pulled back in line. So being able to have easy, simple solutions that are easy to use for an operator, that don't get in the way of their job, is really a prime area of interest. So I think about it from some home Wi-Fi, for instance. Traditionally, setting up a Wi-Fi adapter is very complex. Google developed their Wi-Fi solution, and they took all the complexity out of it. So it's very easy. You set it up through an app on your phone, through a wizard, and they've abstracted all of the security settings from the user. So they analyze what you need and they set that up for you. So those types of solutions are really needed for these small shops. The tens of thousands of small shops out there that do not have the expertise, don't have the budget to pay for the expertise for someone to be able to set up and manage a complex cybersecurity cryptographic protection system. So the solutions have to be easy to use, and the complexity has to be abstracted away from the user.
If I may add something to this, Chris mentions nation state actors, and if I would play a nation state actor, or if I would get enough money to build a specific team, I would go for firmware. I would never go through the data file routes, because this is easier to detect and easier to protect. Firmware is extremely hard to find the modification, right? Because it is proprietary, because nobody looks at it, and you can have control over everything. And if you want to make it even a little bit harder, you can think about hardware trojans, which are even harder to get rid of or detect. So the entire problem space is very complex. So we cannot, and Professor Meinel has mentioned that we have this chain of events, and I would also like to emphasize that in each chain, in each link of this chain, we need to figure out what are security implications and how can we address them.
Okay, Mark, thank you very much. Indeed, the setting is very complex, and of course, our today's panel is a very small effort to address some of the basic issues. Unfortunately, we are out of time because we have already passed our time, and I understand that this is part of a larger event that needs to go ahead. So I have to stop here, and thank you very much, all the panelists, for being here, and providing all these interesting aspects and views. And I appreciate and thank NYU and the Tanton School of Engineering specifically for inviting all of us into this very important panel, which I hope has enlightened your viewers and hopefully something that we can do again in the future. Thank you very much. And we will be happy. I don't know if you have a mechanism, Professor Nikhil, to collect questions from your viewers, and we'll be happy to address them in the near future.
Thank you very much. On behalf of the organizers, I thank all the panelists and Professor Serpanos as the moderator. And we hope that this panel was useful to give you an overview of cybersecurity. We will post the recording on YouTube and send the list to everybody who registered for it. And Gary has posted a link to cybersecurity events which are going on this week at NYU as part of the CISO Cybersecurity Week. So we hope that you will be able to take advantage of all the programming that we have developed. And once again, thank you everybody for joining as panelists, moderator, and attendees. We greatly appreciate that. Bye-bye.
Bye.
Okay,
Thanks for the
thank you
opportunity.
very much. We appreciate it. Thank you. Thank you.